Geogebra session to learn how to do the flange point on your free GeoGebra that you have at home, right? Okay. Now, first thing you want to look for is getting the grid out there, because you're going to want to plot your points well. So that's under view. That's grid right there. It shows you the size points. Okay. Now, lattice points are where the grids intersect here. That's where you want to set up your GeoGebra to keep your algebra easy. So the other thing you want to do is under options, under point capturing, you want to go onto the grid because you want like whole number of points. Okay, great. Now, Kelly, do you know the points that you're interested in? Just pick 3 points.
4, 3.
4, 3, and see, I can just go to the point thing, and notice how it's showing you. I don't have to be really even close. Just right to 4, 3. See that? Boom, there's your A. Pick another one.
-1, 2.
-1, 2. That's good.
And 6, 0.
6, 0. Okay, you can't have any point with a 0.
I lied. 3, 1.
3, 1, okay. Now, we're going to check this because it says it can't, in the packet says it can't be, it has to be scaling. No two sides can be the same. It can't be a right triangle either. So to check that, we go over here and make all the line segments. So let's go from A to B, or not. There we go. From A to C, and from C to B. Notice it also kind of knows that CB we like to call, is that the last one we did?
Mm-hmm. Yeah, CB was last one.
Oh, you know, but then it called it C. I should have done these in the right order. Let's relabel these, because I want this A. See this 5.099, this longest side? That should be really called side C. So we relabel it. Object properties. Label. Where's the name? It's called C. What did I do wrong? Oh, see, now it's calling this C2. What's the shortest side? What do you want to call that? B, right? And this side?
A.
You want to call that A. So let's come back here and call it object properties. Call that. Now, does that make sense?
Yes.
The biggest side, 5.099, is opposite the biggest angle. We can also make sure we don't have any 90-degree angles here just by going up here where it says measure. Angles, select 3 points or 2 lines. So try. Just click on 2 lines. Boom. Awesome. You put another point in. Oh, what happened there? Undo. Just click on this. Boom. See, that's one point with the, there's the angle. Now you try another one. See, you're not, it's hard.
That's close.
Yeah. Let's just do it from here. Oh, I did too much. How about redo? There. And then just click on this and this. There you got that angle. And this and this. We got that angle. Okay. None of those are 90, right?
No.
So we've got the case. It's a scaling triangle, none of them are 90 degrees. Now notice, if you change your mind, you can just grab the point grabber here and go, oh no, I want to be over here. That's legal. It's okay to line things up vertically though. This though becomes what? Oh no, it's not. I thought it was an isosceles triangle. It's not. Okay. So we'll go back to your first choice. Was it back here like that?
Yes.
Okay. Now the flange point comes, do you remember in geometry when you connected the medians? What were the medians in geometry? You take a vertex and connect it to what?
Midpoint.
The midpoint of the other side, right? And those were all concurrent. Same thing with the perpendicular bisectors. Same thing with the altitude. Same thing with the, there's one more, the angle bisectors. Well, it turns out these flange lines will be concurrent in the flange point. But how do you get it? See these circles at each of these, measuring the angle? We're going to make a circle at each corner. Center at the corner, but it'll use the opposite side as its radius. So when you go to constructing the circle, see the choices over here? Circle is center through point. We don't know what the point is. We know what the radius is. Circle is center and radius. So you click on A, and then it says, what do you want for the radius? The side
Do I
opposite.
just say a number?
You want side A, which is 4.1.
Oh.
But to make it infinitely flexible, we're just going to put in letter A there, so it always knows you want to use the side opposite. Okay. There's our first circle. And now we can make the other circle. This is point C. What do we want to use for its radius?
C.
All right. Now, notice how those two circles intersected. Why do they have to intersect?
But that's what the midpoint is on the other side.
Really?
No?
This circle started from A and this circle started from C.
This one-
Couldn't you have the two circles made and they don't quite reach each other and don't intersect? But notice how these two circles, notice how these two circles have radii equal to these opposite sides. Is there a way that these two sides couldn't stretch across the other side? Any two sides long. So that's one of the reasoning questions I'm asking you. Okay. Now, do you see where these are crossing? Where can you find crossing? You go on the menu and find crossing. Intersections. It's tricky because you have, no. You have to hit the thing, hit the command first. Now look at there. Do you see that's perpendicular, like the little button there? Do you see intersection? No. So you got to look around some more. And you know, if you keep sliding around, it'll show you all of them as you go cruising along here. Like this, I think. No, maybe not. You have to keep pulling down each menu. Yeah, so it's a little counterintuitive because they have intersections over here under point, new point, or intersections between objects usually create points. So you have to pick that one. Intersect two objects, so just pick two objects. Yeah, you got the circle, not the other circle. Continue. So there's our 2 points. And now you go over to the line maker, not the segment maker, but the line maker, line to the 2 points. And you just click on the 2 points, boom, and boom. Now let's stop for a second. This is one of the flange lines. The flange point will be on here somewhere, but we have to get the flange lines from the other circles first. Notice what you've got on the side over here. You see this? Right here? What is this D? Let me scooch this over so you can see. What is that D?
That's the point.
No, what's x minus 4 squared plus y minus 3 squared plus 17? What kind of shape is that?
That's the circle.
That's a circle. Which one?
1, 2.
Centered at...
4.
No, see, this is just the...
That's A.
See, you just called this D because it was the next object.
That's point A.
Right, there's the point, there's the center, and what's its radius?
Square root of 17.
Square root of 17, because it's this length here, and if you go over 4 and up 1, do the Pythagorean theorem, you get the square root of 1 squared plus 4 squared square 17. And so what's this thing?
That's with C as the center.
That's the center of 3, 1, right, and this really big radius. Okay. And what's this? What does it look like? 3.6x plus 7.2y equals 43.2. Standard. For what? A line. It's a line. Now, that line is not the intersection of the 2 points, is it? And I want you to do this algebraically as well as GeoGebra. But GeoGebra is going to give you all these sort of stepping stones. You could have written the formula for the circles. Now, getting the formula for this line is a little trickier because you have to get the intersection of 2 circles, which is a real bear, because you got to get, because it's an x squared and x and y squared and y. But if you expand this out, both of these, and subtract them from each other, the x squareds fall out and the y squareds fall out, and you just get something x and y, which is this equation. And you don't have to get actual intersections. It's just important to get this equation, because that's what you want to intersect with another line to get the flange. Okay, we need another circle, don't we?
Yeah. B.
Where? So it's back to circles. Circle with center and radius. So centered at B, radius of little b. Okay. All right. Now, be careful that you pick, well, it'll actually show pretty nice. Find another 2 points of intersection. No, you just pick the thing. You don't have to actually find the intersection points. Just find the things you want to intersect. That circle, that's good. Oh, precise. Precisely. There's your FG.
What about the other circle?
Now you can put, well, actually for now, good. Because, watch what happens. F, G, do they cross? And that's your flange point. Where those two cross. And notice how we've got formulas for those two now. You've got formulas for that next circle. And then this is the intersection of this circle, I think, with this one, and it came up with another line. And now, algebraically, you could solve that system of equations in two lines. Right? You could solve them both for y and whatever. And that would give you the exact points of the flange point. Now, this is the great thing, is GeoGebra will tell you what your answer is supposed to be for your points. Because you can now intersect what objects to get the flange point.
You do it
Careful.
the other. Isn't it the lines?
The lines, right.
See, the other.
Okay. They don't go sound things. Boom. That's one of them. And boom, way over that bingo. And that H then, not H, what do they call it?
6.
Pull the whole thing down. Go to
No, not 6.
Pull the whole thing down. Yeah, it looks like, no, that's just happens to be at the 6. Look up, it labeled it point H. Hold it. How is point H is supposed to be a point? They give us another line. What? Let's stretch this out a little bit more. How is H? That's clearly a point. Oh, capital H. There you go. That's right. Capital letters for points. Geometry. Lowercase letters for the lengths of sides. Or for sides. Okay, so you got the flange point. Now you can find the last flange line to see if it also goes through that.
No, what?
Now you can do the, see there's one more pair of circles we didn't find intersection. Yeah, you can do it. It's going to go through that, but notice how there's two circles you haven't intersected with each other.
Oh, that's right.
So you got to go to intersection. Grab that circle. Although you can quite grab it. And it'll wait until you actually click on something. There you go, and there's your JI. There's your JI, and now we put the line through those two. Line, click, click, bingo, and they all go through H. And also, now you can grab these points and move them around. Hello.
Oh.
And can you get the flange point inside?
There's. Oh.
Where'd it go? It's way out there now. If you get the thing more and more extreme, the flange point starts disappearing. If you get more and more like the equilateral triangle, now where's the flange point?
Inside.
It's inside, yeah. Let's get back to your point, I think it was over here.
4, 3.
Yeah. Okay. Okay, questions? We've got less than 3 minutes. Still simple. Good? Okay.